Today we're going to look at graphing the square root and the cube root. So let's look at the function y equals x squared. And we have a 0, 0, a 1, 1, a 2, 4. If I stick in a negative 1, I get a positive 1. If I stick in a negative 2, I get a positive 4. And we saw on Monday that the y equals x squared and if I take the square root of both sides, I get square root of y equals square root of x squared is x. And then if I switch these, x with the y and the y with the x, what do I get? I get the inverse function. So if I remind you what we did on Monday, what we did is we took a function and then we found the inverse. The easiest thing to do when we find the inverse is to switch points. So if I switch 0, 0, I get 0, 0. If I switch 1, 1, I get 1, 1. If I switch 2, 4, I get 4, 2. If I switch a negative 1, I get a negative 1. Negative 1, negative 1. If I switch a negative 2, 4, I get a 4, negative 2. 4, that point should have been right here. So if I sketch this curve in, you might remember from Monday that inverses are the reflection about the line y equals x. So what we're going to look at today is that all square roots are going to basically have this shape. But you might recall that if we have a u on its side, if we have a, and again, let's just redraw this. If we have a function that is a parabola on its side, this is not a function. Why? Because for every value of x, there is not one y. So when we graph the square root function, we will only graph the top part of this square root. And why? Because when I graph the function y equals the square root of x, if I graph this bottom part, it will not become a function. So let's take a look at this function y equals the square root of x plus 4. So we have the square root, but then we have a number over here that's going to affect our curve. So let's remember how a plus 4 affects our curve. If I just have this function, just the square root of x, I'll have half of a parabola on its side. And then what does that mean if I add 4 to each one of those points? Well, let's see what it means. If I stick in an x equals 0, I get 0, the square root of 0 is 0, and 0 plus 4 will be 4. So at 0, I'm going to have 4. If I stick in a 1, the square root of 1 is 1, and 1 plus 4 is 5, so I'm going to get a 1, 5. And then if I plug in the next square root that you probably know is a 4. And why did I pick 4? The square root of 4 is 2, and 2 plus 4 is equal to 6. So we're going to come all the way down here to 4 and graph 6. And remember, the square root looks like half of a u. That other half is there, but we don't draw it in there because then it would not become a function. Now this next example is a square root, but the square root has x plus 4 all under the radical sign. So again, kind of keep in mind that we're going to have this square root looking function, but how does it move or how does it shift? So what we want to first do is pick a point where the inside is equal to 0. Why? Because that's the starting point of a normal square root. So what value will x be such that x plus 4 will equal 0? Well, that'll be a negative 4. Now watch how this works. If I stick in a negative 4 plus 4 is 0, and the square root of 0 is 0. So I'm going to have the point negative 4, 0. Now some of you guys that are seers will be able to see this u on its side, but let's go find that point out exactly. Okay. Now the next square root that you guys know is probably 1. So what value will, if I plug in x plus 4, will I get a 1? Well, let's choose the number negative 3. So if I stick in a negative 3, I'll get the square root of 1, and the square root of 1 is 1. Now, I'm starting to see that shape of my sideways u. Let's go back and make this inside. What's the next square root, you know? 4. So if I subtract 4 from both sides, if x equals 0, 0 plus 4 is the square root of 4, and the square root of 4 is equal to 2. So I have a 0, 2, and my square root function, graph it like a, again, kind of keep in mind that you have this sideways parabola, but we don't graph that in there because we have no function.